In this module, we'll focus on glued laminated timber and cross-laminated timber. Both of these products are manufactured from sawn timber feedstock, and we will look particularly at applications and design principles for both of those products. Glued laminated timber is manufactured by gluing together pieces of sawn timber. They're glued face to face so that their grain is parallel, and that way a large and deep member can be manufactured, so that it's simply manufactured as a deep member like this out of simple sawn timber. Cross-laminated timber is also manufactured out of sawn timber, but it's manufactured by making up layers of timber, so that the timber is put side by side, and then each alternate layer has its grain in opposite directions, so it can make up a deep and large panel member. So that's the essential difference between cross-laminated timber and glued laminated timber. Glued laminated timber can be made straight. If we glue up straight pieces of timber, we get straight glulam. By pressing it into a curved state while the glue is moist, then a curved piece of glulam can be manufactured. And in this slide, you can see some very impressive curved glulam. You can see the tight radius of the curvature and the artistic lines of that particular building. Curved and tapered glulam requires special design treatment, so that the curve introduces stresses in the timber, and those stresses must be taken account of in the design process. And Appendix E of AS 1720 Part 1 gives us the tools to do those analyses. But you can see we can achieve quite large spans with curved glued laminated members. Artistic structures are also possible, and architects often specify rather unusual shapes, but again, all of these can be designed using the simple tools that are in front of us in AS 1720 Part 1, Appendix E. Architects can draw their inspiration from many different places, and each time they do, they give us a new challenge in the design of structural timber. So here are portal frames with no knee joints. It's made from one long piece of curved glued laminated timber. Glulam can be used in harsh environments, and when used in a harsh environment where moisture content is going to change significantly, we need to pay particular attention to connections, that they don't trap moisture, that they don't expose steel elements to the potential of corrosion. We need to also look at continuous air circulation so that the air is moving around the timber at all time, and require also conservative estimates of creep, because the moisture movements may accentuate the creep that timber is exposed to under long duration loads. Glulam can be manufactured to a number of different appearance grades. So as well as the structural grades, which are in Australia GL grades, there are also appearance grades that signify what the surface finish is required. The highest appearance grade is A. So most product that is produced in Australia, and certainly the product that has an architectural use, is appearance grade A, and it's suitable for varnishing or giving a clear finish. Appearance grade C is a rough finish and is totally appropriate if the glulam is going to be hidden or used in an industrial application. Those two photos, the top one is appearance grade A, the bottom one is appearance grade C. So cross-laminated timber. Cross-laminated timber is custom made. So when a designer says, I want a panel of this size, that is the size panel that is actually manufactured. And we can manufacture wall panels, floor panels, and all of them perform in much the same kind of way. They are good at carrying out-of-plane loads, and they are good at carrying in-plane loads. So that when we look at the type of structure that is shown in the lower photograph of this slide, it shows panels which have capacity to carry lateral forces as structural elements in that building. The whole building arrives as a flat pack, as shown in the upper right-hand picture of that slide. CLT construction then is simply assembling the pre-manufactured panels on site. As you can see, they've already got cutouts for the windows. They can already have chasing in it for the wiring and the plumbing, so that fit out of the building is accelerated by use of that type of construction. Putting these large or connecting these large elements together make use of large screws. So many of these CLT buildings are held together by screws of about this size. And they are totally appropriate for going through slabs that are about that thick. Cross-laminated timber is lightweight, so it's suitable for poor foundation conditions. Often in the past, people have found that they can only build a 6 or 7 story concrete building because foundations are limiting the weight of the building. But by using cross-laminated timber, using essentially the same construction techniques, they can achieve a 10-story building. In this case here, it's a 9-story building that was erected out of cross-laminated timber on that dodgy site in the UK. The design of cross-laminated timber is facilitated by a number of guidebooks, and there are European, Canadian and US guidebooks. Any of those could be used in Australia and have been used in Australia. Essentially, they're using transformed sections, where we're using the full properties of all of the laminates that have the timber with the grain parallel to the load direction, and reduced properties for the laminates where the grain is perpendicular to the load direction. So it uses classic strength of materials transformed section theory to determine the performance of the cross-laminated timber sections. So there are different properties and capacities in each direction. If we think of a floor slab, because the outer laminates have the grain running in one direction, so the top laminate and the bottom laminate have the grain running in the same direction, they have higher capacity in that direction. So spanning in this direction, they have higher capacity to spanning in the other direction. It is an orthotropic material, but the difference in the two directions is reduced by the manufacturer. And connecting them together, screws and plates or dowels can be used to connect them together. Architectural solutions can make use of the timber so that we have timber exposed in walls, in ceilings and even in stairs, so that the cross-laminated timber becomes an architectural solution as well as an engineering solution. Both of these products, glued laminated timber and cross-laminated timber, are appropriate for combined architectural and structural applications. They are useful for large spans. Glulam as beams in large span applications. All of the grain is parallel to the direction of span, and they are very structurally efficient. It's also possible to make glued laminated timber in curved shapes, so that it can be used for combined architectural and structural applications. The Glulam grades and the Glulam design methods are well documented in AS 1720.1. Cross-laminated timber can be designed using other sources, European and North American guidebooks for the design of cross-laminated timber. It's suitable for large slabs, so floor panels, wall panels. Its fast construction technique means that it's a cost-effective way of using lots of lightweight timber in a structural system.